Hi everyone, welcome to week 15 of Ordinary Level Junior Cycle. So today we're going to be looking at probability and expected value. So we're going to be going through a couple of examples and then we're going to go to the exam papers and do out a couple of solutions. So first of all, we're going to look at relative frequency and probability. So if we look at the example on the screen there, suppose we roll a die which has a sample space of 1, 2, 3, 4, 5 and 6. That means that if you roll a die you can get any of those numbers. And say we get the following results from 10 rolls. I'm just going to underline 10 rolls because that gives us the number of trials or the number of experiments that were carried out. So we have a number 1, a number 3, a number 1, a number 4, a number 5, a number 2, a number 6, a number 1, a number 6, and a number 5. So we can count the frequencies and then count the relative frequencies for each outcome in our sample space. So it tells us there that the number 1 was rolled 3 times. So to get the relative frequency there, so the number 1 was rolled a total of 3 out of 10 times. So if you put that into the calculator, you'll get 0.3, so that's where the relative frequency is coming from. The number 2 was rolled once, so it only occurred once. So it was 1 out of the total of 10, which is 0.1. The number 3 was rolled only once, and that's 1 out of 10 times. So again, that's 0.1. The number 4 was only rolled once as well, so the number 4 is going to be once out of the total of 10, which is 0.1. Then we have the number 5, which was rolled twice, so it was twice out of the total 10 times, and that's 0.2. And then finally the number 6 was rolled twice as well, so the number 6 was rolled twice out of 10 times, which is 0.2. Now, what you should do is add up all of these frequencies in decimals. So you're adding 0.3 plus 0.1 plus 0.1 plus 0.1 plus 0.2 plus 0.2. When you add them all up, you will get 1. And that indicates that you are correct. So we can see that the sum of the frequencies is the number of observations, which is 10, and the sum of the probabilities is 1. So this will always be the case, and it is a good way to check if your frequencies are correct. So I'm just going to put a star here. The sum of the relative frequencies or probabilities of all of the possible outcomes is 1. So we're going to go on to an example here now before we move to the exam questions. Okay, so John and Kathy are playing a game of chess. Suppose that Kathy is a better player and that she's twice as likely to win as John. What is the probability that Kathy wins? So that's what they're asking there. What is the probability that Kathy wins? So we are told that the probability of Kathy winning is the same as 2 times the probability of John winning. Assuming that there is no stalemate, so either John or Kathy must win, so you have only 2 outcomes, so the sample space is 2 outcomes. So this means that the probability that Kathy wins plus the probability that John wins is going to equal to 1, because remember the sum of the probabilities is always 1. Or if we rearranged it to get that the probability of John winning would be 1, which is the total, minus the probability of Kathy winning. Combining these 2 equations, we can see that the probability of Kathy winning is equal to 2 times 1 minus the probability that Kathy winning. Because remember, we rewrote this as the probability of John winning. And because of that, the probability of Kathy winning is 2 out of 3, or 2/3. So the first question I pulled there is from 2012, paper 2, question 7. So in a survey, 1,500 people were asked which national radio station they normally listen to, and the results of the survey are given in the table below. So the first question there, how many of the people surveyed do not listen to a national radio station? Okay, well we're told that the total there is 1,500 people, so the way we get the number of people who did not listen to a national radio station, so this is what we're trying to find out here. So we're going to take all of the frequencies away from 1,500, so it's 1,500 minus, so we're going to add them all up, so 375 plus 195 plus 120 plus 45 plus 165. So it's going to be 1,500, and when you put that into the calculator, it's 900. So 1,500 minus 900, you get 600. So 600 goes in that space there. Now the next part is part B, so complete the table above. So the relative frequency as a fraction. So remember, the relative frequency is always the frequency out of the total. So the first one is done, 375 over 1,500. The next one is 195 over 1,500. The next one is going to be 120 over 1,500. Then 45 over 1,500. And then 165 over 1,500. So then we just need to convert them to a decimal, so you can put these directly into your calculator. So 375 divided by 1,500 is 0.25. 195 divided by 1,500 is 0.13. The next one is done for us, which is 0.08. 45 divided by 1,500 is 0.03. And 165 divided by 1,500 is 0.11. And then 600 divided by 1,500, put that into the calculator and you will get 0.4. So that's for part B. For part C, find the sum of the relative frequencies written as fractions. So you need to write these actually out as fractions. So it's 375 over 1,500 plus, so remember sum is when you add them all together, 195 over 1,500 plus 120 over 1,500 plus 45 over 1,500 plus 165 over 1,500 plus 600 over 1,500. Now when you add all of those together, you'll get 1,500 over 1,500, which is 1. That's it for part C. On to part D now. Find the sum of the relative frequencies written as decimals. So you're literally just going to add all of the decimals up together. So just scroll up to remember what we had. So it's 0.25 plus 0.13 plus 0.08 plus 0.03 plus 0.11 plus 0.4. And when you add all of those together on the calculator, you will get 1, which indicates that you're correct. Okay, Jackie wrote the relative frequencies as percentages. She found their sum to be 80%. Do you think her calculations are correct? And give a reason for your answer. Well, she must be wrong, because remember, the sum of all of the relative frequencies should equal 1, or 1 over 1 in fraction, or 100%. Hers equals 80%, which means she must be wrong. So the answer is no, and the reason is that they should add up to 100%. So that's for part E. For part F then, Dennis looked at the data and said, I can find out how many people in the survey normally listen to local radio. Do you agree or disagree with Dennis? Explain your answer. So the answer here is that it's no. You disagree with Dennis, and the reason is because some people may not listen to any radio at all. It's a subjective question. So the answer is no. And just a justification or an explanation is that some people may not listen to any radio at all. And that's the end of that question. So the next one I have here is 2012, paper 2, question 8. Sorry, I'll just scroll in. There we are. Okay, so Jack rolls a fair die and spins a fair spinner as shown. So you've got two different things going on here. So you're rolling a die and spinning a spinner. So complete the table below showing all of the possible outcomes. Okay, so the first one there is done for us. So rolling a 6 and spinning an A. So the next one would be rolling a 1 and spinning an A. Rolling a 1. So rolling a 1 and spinning a B. rolling a 1, spinning a C, rolling a 1 and spinning a D. Next one will be rolling a 2, spinning an A, rolling a 2, spinning a B, rolling a 2, spinning a C, rolling a 2, spinning a D. Next one will be rolling a 3, spinning an A, rolling a 3, spinning a B, rolling a 3, spinning a C, rolling a 3, spinning a D. So continue on, so rolling a 4, spinning an A, rolling a 4, spinning a B, rolling a 4, spinning a C, rolling a 4, spinning a D. Next one will be rolling a 5, spinning an A, rolling a 5, spinning a B, rolling a 5, spinning a C, and rolling a 5 and spinning a D. And the last one then, rolling a 6, spinning an A, rolling a 6, spinning a B, rolling a 6, spinning a C, and the last one is done, rolling a 6, spinning a D. So first of all, for part B there, it says how many different possible outcomes are there. So if you were to count up all of the different outcomes there that you have, it's equal to 24. So you could physically count them. How many outcomes consisted of an odd number and a B? So let's have a look here. So how many outcomes consisted of an odd number and a B? So that's the first one, 1 and B, 3 and B, and 5 and B. So the answer there is 3. For part D, what is the probability that the outcome will contain an even number? Okay, so I'm going to get a highlighter here. Let's find all of the outcomes with even numbers. So we'll have 2, 2A, 2B, 2C, 2D, 4A, 4C, 4D, 4B, 6A, 6B, 6C, and 6D. So if we count them up, we have a total of 24, and out of that is 12. So 12 out of 24, which is going to break down to a half. And I think that's, yeah, that is the last question there. So now we're going to go on to the next question, which is 2014 paper 2. Okay, so for this question, a game is played using 2 spinners shown below. The first spinner has 3 segments labelled 2, 4 and 6, and the arrow has the same chance of stopping at each number. The second spinner has 6 segments labelled A, B, C, D, E and F. The arrow has the same chance of stopping at each letter. So 2 possible outcomes are 2A and 6 and D. List all of the possible outcomes on the table below. So this is kind of similar to the question we're just after doing. The first one is done there for us. So 2 and A, the next one will be 2 and B. The next one after that will be 2 and C. The next one will be 2 and D, 2 and E, and 2 and F. So the next one then after that will be 4 and A, 4 and B, 4 and C, 4 and D, 4 and E, 4 and F. Then we have 6, so 6 and A, 6 and B, 6 and C, 6 and D is done, 6 and E, and 6 and F. So that's for part 1. Part 2, list how many outcomes contain the letter E. So let's find how many outcomes contain the letter E. So 1, 2, 3. The answer is 3. For part 3, what is the probability that the outcome contains the letter E? So what is the probability that the outcome contains the letter E? So it's going to be 3, so 3 possibilities out of a total of 18. If we put that into the calculator, it breaks down to 1/6. What is the probability that the outcome contains the number 6? So if we were to go along and see how many different options we have for 6, so we have 1, 2, 3, 4, 5, 6. There are 6 options that contain the number 6. So that's going to be 6 out of 18. And that breaks down in the calculator to 1/3. For part 5, what is the probability that the outcome contains an E or a 6 or both? So we have 3 options containing an E, so that's 1, 2, 3. And we have another couple of options containing a 6, so we have 1, 2, 3, 4, 5, and 6. So if you add all of those up, it's 8 out of 18. So 8 out of 18. and that breaks down to 4/9. And that's it for part 5, and I think that's the end of that question. Yep. So we're moving on to 2014 sample paper 2 now. So a bag contains red discs, blue discs, and white discs. In an experiment, each student in a class of 24 takes out a disc and records the colour and replaces it. This is repeated 10 times. I'm just going to underline this, that it's repeated 10 times. The results from the class are recorded in the table below. So first of all, in your opinion, why is the number recorded for red greater than for blue or for white? So it is most likely that there are probably more red discs than blue or white in the bag, and that would explain why more red got selected than the others. So we're just going to write out a sentence for that. So there are probably more red discs than blue or white. So for part B, complete the table above. So first of all, the frequency, to get the total, we need to add the 3 frequencies, so 123 plus 78 plus 39. You can put that straight into the calculator and you'll get 240. Relative frequency is the frequency over the total, so it's 123 over 240. We'll put this into a decimal and you get 0.5125. Next one is 78 out of 240. Put that straight into the calculator and you get 0.325. Next we have 39 divided by 240. Put that straight into the calculator and you get 0.1625. Now to get the percentage of the total frequency, you just multiply the decimal by 100. So that's 51.25, 32.5, and finally 16.25. For part C, use the results from the table above to estimate the probability of getting each colour when a disc is taken from the bag. So first of all there, the probability of getting or picking out a red disc is 0.5125. The probability of picking out a blue is 0.325. And the probability of picking out a white is 0.1625. Now I've actually crossed out part D and part E because it isn't relevant to the new junior cycle course, so we're going to move on. So we're on to 2015 paper 2 now. So question 1, so the songs on Gavin's phone are shown in the table below. So Usher is left blank, Pharrell, he's 15 songs, he's 4 songs by Ed Sheeran and 3 songs by Hosier. Gavin has 30 songs on his phone in total. Find out how many songs by Usher are on Gavin's phone. So we have a total of 30. So if we take away the other number of songs, we'll get what's left over, which will give us the number of Usher songs. So it's going to be 13, take away 15 plus 4 plus 3. And that's going to be 30, take away 22. You can put that straight into the calculator and the answer is 8. So we can fill in 8 there in the place of Usher. So we'll go on to part B. Gavin plays a song at random on his phone. Find the probability that this song is Hosier. So he has 3 songs by Hosier out of a total of 30. Now we always try and break this down, so 3 over 30 will break down to 1 over 10. Part C. Find the probability that this song is by Ed Sheeran or Pharrell. Okay, well it's a total of 30. So how many songs do we have by Ed Sheeran? We have 4. And how many songs do we have by Pharrell? We have 15. So 4 plus 15 over 30. And that will give you 19 over 30. And we can't break that down anymore. Gavin plays a song by Ed Sheeran and then plays a song by Hosier. How many different ways can he do this? Remember that he has 4 songs by Ed Sheeran and 3 songs by Hosier. Okay, so we're just going to write down the information. So we have 4 songs by Ed Sheeran and we have 3 songs by Hosier. So to get the total number of combinations, we actually multiply both of those together. So 4 multiplied by 3, the answer is going to be 12 different ways. And that is the end of that question. So the next one is 2016 paper 2 question 1. So shirts in the clothes shop come in the following 4 sizes: the small, medium, large and extra large. Christina makes the following list showing the size of each of the shirts in the shop. So write down the total number of shirts in the shop. So what you need to do is you add up all of those sizes together. And when you add them all up, so if we just see we've 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We have a total of 18 there. So you literally just add them all up. For part B, use Christina's list to fill in the frequency table below. So how many times do you see a small size turn up? So we've 1, 2, 3. So it's only 3 smalls. Let's look at the medium. So we've 1, 2, 3, 4, 5, 6, 7. So 7 mediums. Let's check how many large we have. So 1, 2, 3, 4, 5, 6 large. And finally extra large we have 1, 2. 2 extra large sizes. So if we go on to C, Christina picks one shirt at random. Find the probability that it is a large shirt. So how many large shirts do we have? We have 6 out of a total of 18. Now remember, we need to break this down. So if you put that into the calculator, you'll get a third. For part D, Christina puts one of the large shirts on display. She then picks another shirt at random from those that are left. Now, if she puts one of the shirts on display, there was a total of 18. If she puts one of them on display, that means we're going to have 17 left. So the total is going to be out of 17. So what is the probability that it is a small shirt? Well, how many small shirts do we have? We have 3. So the probability is going to be 3 out of 17. And we can't break that down anymore. So it's 3 out of 17. Okay, so we're going to go on to this question here. So 2017 paper 2. So Linda spins the spinner shown below. It has 3 sectors: grey, black and white. So you can see them there in the diagram. Measure the size of the angle in each sector of Linda's spinner and write your values into the table below. So in this case, if it's saying measure the size of the angle, you're using your protractor. So I can't use a protractor here on the screen, but if you were to use one directly onto the page, now the grey is kind of obvious that it's going to be 90 degrees. The black will measure an angle of 120 degrees, and then the white will measure an angle of 150 degrees. So when you use your protractor, that's what you should be getting there. Linda is going to spin her spinner 60 times. Use your answer for A part 1 to estimate how many times you would expect it to land on a grey. Well, the angle for grey is 90 out of a total of 360. Multiplied by the amount of times that she spins it, which is 60. You can put that directly into the calculator, so it's going to end up as a quarter. Multiply by 60. When you multiply a quarter by 60, it's 15 times. That's the answer for part 2, or A part 2. If we go on to B part 2, or part 1, sorry. The table below shows the probability of 4 events, A, B, C and D. Fill in the 4 missing values in the table below to show the probability of each event as a fraction, a percentage and a decimal. Write the fraction in its simplest form. So the first one is done first there. A quarter is 25%, and that's the same as saying 0.25. A half is 50%, and that's the same as saying 0.5. 2/5, that's the same as saying 40%. If you were to put 40% as a decimal, it would be 0.4. And then D, so 2%. How would you write 2% as a decimal? So it would be 2 out of 100. And break that down to the simplest would be 1 out of 50. Putting that as a decimal is 0.02. So the last part of that question is to mark and label the probability of each of the events A, B, C and D on the scale below. So for A, we're going to look at the decimal here would be easiest. So for A, it's 0.25, so 0.25 would be roughly here. I'm going to mark that in there. So A. The next one, B, is 0.5, so that's going to be here. The next one is C, which is 0.4, which is going to be here. And finally, D, which is 0.02, so it's going to be roughly here. So I'm going to put in D. There. And I think that is the end of the question. It is. So I'm going to attach some extra links for some extra video tutorials and extra exam questions with marking schemes. And I advise that you go to them just for some extra material. And just be very careful as well when they're asking you to express fractions as simplest form. You need to make sure and do that, or you won't get your full marks. And usually with probability, they will want it in its simplest form. You can convert that directly on the calculator. So I will speak to you next week, and make sure to check out all of the extra links in the chat.